All right, let's jump right in. Today we're talking about a pretty radical new way of thinking about code called the Rifter's Way. And get this, it's not just another programming language. Nope, it's a whole new philosophy for how we build the software that our lives actually depend on.
To really understand it, we've got to start with a heavy question. Seriously, what if someone's very next breath depended completely on the code you just wrote? Because this isn't just a thought experiment. It's the exact scenario that sparked the whole Rift ecosystem. We're talking about a sleep apnea machine, where a tiny coding error, a race condition, doesn't just freeze an app. The consequence is terrifyingly real. It's a failure to deliver oxygen when someone needs it most. And that right there, that's the core problem. Our traditional ways of writing software are just fundamentally disconnected from the human experience, and that disconnect is creating totally unacceptable risks in our most critical systems.
So, let's really dig into that high-stakes world. This is a place where software isn't just about cool features or slick UI, it's literally about life support.
So the technical issue here is something called concurrency. It's when you have multiple streams of code running all at the same time. One stream is watching to see if breathing is stopped, and another one is controlling the ear pressure. If those two don't sync up perfectly, the machine fails. It really drives home that safety isn't just about preventing crashes. It's about making sure the code's logic perfectly mirrors the needs of the human it's supposed to be protecting.
And that realization leads us directly to the new philosophy designed to fix this exact problem, the Rifter's Way. Okay, this is where things get really fascinating. On one hand, you have traditional coding, which kind of expects developers to be like these multi-threaded CPUs, juggling a million abstract ideas at once. But Rift, it's built around how humans, and this is key, particularly neurodivergent thinkers, actually achieve deep focus, one complete, validated thought at a time. It literally builds the concept of care right into the system's architecture.
So how do they pull this off? Well, their core metaphor is tokens as breath, and it makes perfect sense when you think about it. You can't start exhaling halfway through an inhale, right? It's a complete cycle. In Rift, every piece of information, what they call a token, has to be fully formed, understood, and checked before the program can even think about taking its next step. It forces this steady, reliable, and totally predictable rhythm.
And this idea extends to something as fundamental as computer memory. We usually think of memory as just this empty bucket where we dump data, but not in Rift. In Rift, memory is a foundational contract. Before you can even put any data into memory, you first have to define the rules, the trust, the access, the safety for that little piece of memory.
All right, so let's look at the code itself and see how this philosophy builds a completely different way of thinking. Welcome to the memory-first paradigm. Everything, and I mean everything, in Rift is built on this triplet token. Now pay close attention to the order, because this is the whole secret sauce. Unlike most languages where you'd say, this is an integer and its value is 5, Rift forces you to start with memory. First, you define the governance contract for the memory space. Only then do you define what type of data it is, and finally, you can assign the value. Safety and structure come first, always. No exceptions.
And the coolest part is that this core model is incredibly flexible. It can run in two different modes. You've got classical mode, which is exactly what you want for most safety-critical stuff. It's super strict, sequential, and predictable. But then it also has this high-performance quantum mode. This mode allows for massive parallel processing, but it keeps things safe by cleverly waiting to do the final checks until a value is actually needed, kind of like how a quantum state is only defined the moment you look at it.
So as you can probably tell by now, Rift isn't just one language. It's a whole ecosystem designed from the ground up to enforce this philosophy of trust and safety.
So at the center of it all, you have Riftlang itself. Backing that up is LibRift, which is the foundation that enforces all these safety rules we've been talking about. And this next part is really clever. Golang acts like a secure translator, a bridge that lets Rift work safely with other code, like Python or Java, so you can add this layer of trust to systems you already have. And finally, NLink is the optimizer that makes sure it all runs fast without ever breaking those safety contracts.
And, none of this was an accident or happened overnight. This entire complex ecosystem started from these simple, human-centric ideas, literally sketched out by hand. It's just a powerful reminder that the goal was never just to build some new tech, but to better align our technology with real human needs and the way our brains actually work. So where is all of this headed? Well, the vision is a heck of a lot bigger than just another programming language.
So if there's one thing to take away from all this, it's this. Rift isn't just a tool.
It's a blueprint for an entirely new foundation for computing, what its creator calls an operating system for trust. A world where safety, policy, and human-centric design are the default, not a feature you bolt on at the end.
And that kind of leaves us with a final thought to chew on. Just imagine for a second, if our most basic tools, our programming languages, were designed from the ground up with care and responsibility baked in, what kind of world could we really build then? What other impossible problems could we finally solve?